Hello students, this is Nilanjana Sanyal from My Math Friend Online and ePorashna. In our last session, we had done an algebraic division, and even in this session, we will be performing another algebraic division using the long division method. So first of all, let us write down the sum. The sum is 8 plus 1 by 27 y to the power of 4 divided by 2 minus 1 by 3 y square. This is our dividend and this is our divisor. So we have to perform this division using the long division method. In our last session, we had the steps of the long division method in front of us, but in this session, we do not have them in front of us, but we do have them in our minds. So let us see how much do we remember. Let us try to recall the steps and perform the long division. You might be thinking that this is such a weird type of a sum with the fractional coefficients, but I have deliberately taken up this sum to make you familiar with this type of fractional coefficients, so that if you ever come across such a type of a sum, you do not get afraid. So what was the first step of the long division? Right. First of all, we have to arrange the dividend and the divisor in the descending powers of the common variable, which in this case is y. So we have to check whether our dividend and our divisor are in descending orders of y or not. Let us first check the dividend. Both the dividend and the divisor, both of them are binomials. They are containing 2 terms each. Coming to the dividend part, the first term is a constant term. It is 8. 8 can be represented as 8 into y to the power of 0, because anything raised to the power of 0 is 1. So it is 8 into y to the power of 0 plus 1 by 27 into y to the power of 4. So the power of y is increasing from 0 to 4. Therefore, the dividend is arranged, but it is arranged in ascending order. But we have to arrange it in descending order. So the highest power will be coming first. So let us rewrite the dividend in descending order of y. So 1 by 27 into y to the power of 4 comes first, and then comes the constant term plus 8. And now coming to the divisor part, we see that the divisor is also arranged in ascending order of y, because 2 is 2 into y to the power of 0, and this is y squared. So 0 to 4. The power of y is increasing, so it is arranged in ascending order. We have to arrange these 2 terms in descending order of y. So minus 1 to y 3 into y square comes first, and then is plus 2. Then comes plus 2. So this is our divisor. This part is our dividend and this is our divisor. This brings us to the end of step number 1. Now coming to step number 2. What was step number 2? Right. We have to check the dividend in order to see whether the dividend contains terms involving every power of y, starting from the highest power. The highest power of y is 4. So the dividend should contain terms involving y to the power of 3, y to the power of 2, y to the power of 1, and there is the constant term which is actually having y to the power of 0. So we see that there are 3 missing terms which should be inserted in between these 2 terms. And what will be the coefficients of those 3 terms? Obviously equal to 0, because these 3 terms actually do not exist in the dividend, in this dividend. We are inserting them just to make our division process simpler. So we know anything when multiplied by 0 gives us a 0 product, and which in turn when added to something leaves the original expression intact as the sum. So we get this expression when added to 0. We get back this expression when added to 0. Therefore, the coefficients of those missing terms will be 0. So let us insert the 3 missing terms. One by 27 into y to the power of 4 plus 0 into y cube plus 0 into y square plus 0 into y plus 8. This is our final form of the dividend, divided by minus 1 by 3 y square plus 2. The divisor can be kept as it is. See, in this divisor, we do not have any term containing y to the power of 1 or y. But we can keep the divisor as it is. We need not insert any term containing y. And the last step, or the last sentence of step 2 says that we have to arrange the dividend and the divisor. Let us take right over here. With the long division symbol. So the divisor comes outside the long division symbol. We have minus 1 by 3 into y square plus 2. And under the long division symbol, we have 1 by 27 into y to the power of 4 plus 0 into y cube plus 0 into y square plus 0 into y plus 8. This brings us to the end of step 2. Now, what was our step 3? We have to perform the division now. So the step 3 said that first of all, we have to divide the first term of the dividend by the first term of the divisor. So let us take up, say this is our rough work area. So we have to divide 1 by 27 into y to the power of 4 divided by minus 1 by 3 y square. So these two are monomials. It is basically a monomial division, dividing a monomial by another monomial, and we all know how to perform a monomial division. So the result of this division will be minus 1 by 9 into y square. There's this minus sign in the denominator which will be coming over here, and this is 1 by 3, so this will be going to the numerator part, and this will be coming down 27. So 3 divided by 27 will be giving us a 1 by 9, and it is y to the power 4 divided by y square will be giving us a y square. So this is the result of this monomial division, which is the term of the quotient. Let us write this at the top of the long division symbol. So we have minus 1 by 9 y square. Next, what do we have to do? Yes, right. We have to multiply this term with every term of the divisor that are present. So what we do is we write minus 1 by 9 y square into minus 1 by 3 y square plus 2. And what will be the product? Obviously, minus multiplied by minus will be giving us a positive value, positive result. And 1 by 9 multiplied by 1 by 3 is 1 by 27. And y square multiplied by y square is y to the power of 4. And minus 1 by 9 into y square multiplied by plus 2 gives us a minus 2 by 9 into y square. Next, we will be writing this product as the next line under this dividend, line. And we will be writing like terms. I will be writing 1 by 27 y to the power 4 under this 1 by 27 y to the power 4. So we will be grouping the like terms. We will be writing the terms beneath the like terms. So this comes over here, and we do not have any term in the product which has a y to the power 3. So we skip this part and we come to this part. We write minus 2 by 9 into y square beneath plus 0 into y square. And next, what we will be doing? We will be performing a subtraction. That means we will be changing the signs of all of these terms in the second line, and we will be adding the like terms. So 1 by 27 y to the power of 4, and this is minus 1 by 27 y to the power of 4. These two get cancelled. This is 0 into y cube. We can bring this term down, but this doesn't have any meaning. 0 multiplied with anything will be giving us a 0 result. So we just leave this. And we bring down this 0 multiplied by y square, 0 into y square plus 2 by 9 into y square will be giving us a simple 2 by 9 y square as the result of the addition. Next, we are subtracting the entire, we are taking the entire dividend and we are subtracting this product from the entire dividend. Some of you may be wondering that in arithmetic, when we perform long division, we bring down a single number at a time. So, can we bring down this single 0 into y, because this is the next term? Can we bring down one term at a time? If we bring down only 0 into y, that is the next term. If this becomes our new dividend, you see the first term of this dividend is 2 by 9 into y squared. So we will have to this is 2 by 9 into y squared divided by minus 1 by 3 y squared. Why are we performing this division? Again, because step 4 said that this is the remainder of the subtraction. This is the result of the subtraction, which is the remainder. And we have brought down this term. So this becomes our new dividend, and if it is equal to 0, we stop. But 2 by 9 y squared is not equal to 0. It can be equal to 0 only if y equal to 0, otherwise not. So the remainder is not equal to 0, and the degree of this polynomial is 2. The highest power of y in this polynomial is 2, as well as the highest power of this divisor is 2. That is, the degree of the divisor is 2. So the degree of this remainder is not less than that of the divisor. So we have to continue our division. So we have taken the first term of the dividend and we have taken the first term of the divisor. And we are performing the division. Both are monomials. So these two will get cancelled, and 2 by 9 divided by minus 1 by 3. So again we will be having a negative result, and it will be equal to minus 2 by 3. So which will be written as the next term of the quotient over here at the top. Next, what do? We multiply this minus 2 by 3 with all the terms of the divisor. So minus 2 by 3 into minus 1 by 3 y squared plus 2 equal to 2 by 9 y squared minus 4 by 3, right? So which will be our second line over here. So 2 by 9 y square comes over here beneath 2 by 9 y square. But where should we write this minus 4 by 3? Because minus 4 by 3 is a constant term. We are having only two terms in this first line. One is 2 by 9 y square and the second one is 0 into y. So we are not having any constant term over here. So where should we write this? Therefore, I always recommend students to bring down each and every term. That is, if you subtract, we have to bring down each and every term because we are subtracting the product. This is the product from the dividend. This is the entire dividend up to plus 8, and this is the entire product. We are subtracting the product from the entire dividend, and what all terms come as the result, we write all of them. And next, we take the first term of the dividend, that becomes our new dividend, and we take the first term of this dividend and divide that with the first term of the divisor to get a new term of the quotient. And with that term, we multiply every term of the divisor to get a new second line. That is the way we perform the long division. So now we are having 2 by 9 y square and minus 4 by 3. It is a constant term. So it should be written beneath plus 8, which is a constant term as well. And we'll be performing a subtraction, so the signs will get changed. Plus becomes minus and minus becomes plus. So these two get cancelled, and 0 into y, we can leave it as it is because it doesn't have any meaning. It is basically equal to 0. So now 8 plus 4 by 3. What is 8 plus 4 by 3? 8 is a whole number and 4 by 3 is a fraction. So let us perform the addition over here. 8 plus 4 by 3 is equal to, let us convert this whole number to an equivalent fraction containing the denominator, containing 3 as the denominator. So if we write this, 8 can be written as 24 by 3 because 24 divided by 3 gives us 8. So it is basically equal to 24 by 3 plus 4 by 3, which gives us 28 by 3, right? So our result is 28 by 3. This is the remainder. This is the result of the subtraction, which is the remainder. Now, should we perform the division once more? We are having a single term. It is not equal to 0. So the remainder is not equal to 0. But what is the degree of this expression? This is a constant term. And 28 by 3 can be written as 28 by 3 into y to the power of 0. So the degree of this constant term is 0. Degree of any constant term is 0. But the degree of this divisor is 2. So the degree of this remainder is less than the degree of the divisor. So the step 4 said that when we have a situation where there is a finite remainder, but the degree of that remainder is less than the degree of the divisor, we stop the division and we keep this expression as the remainder of the division. So we will be writing our answer as, let us write the original expressions, the dividend and the divisor. 8 plus 1 by 27 y to the power of 4 divided by 2 minus 1 by 3 y square is equal to quotient equal to minus 1 by 9 y square minus 2 by 3 and remainder equal to 28 by 3. This can be, the answer can be written in this form, or you can write the answer as minus 1 by 9 y square minus 2 by 3 plus 28 by 3 divided by this divisor. 2 minus 1 by 3 into y square You can write the answer in any of these two forms. You can write quotient equal to this part, the top part, the terms that are written on the top of the long division symbol, and the remainder is the part that is at the bottom. The bottom part is the remainder and the top part is the quotient. Or else we can write the quotient and the remainder in the same line. We write the quotient first, we put the plus sign and we put the remainder in the numerator and put the division symbol. We put this as a fractional form. The remainder goes to the numerator and the divisor comes down as the denominator. Okay, so we can have the answer in this form as well. So we have performed a polynomial division using the long division method having a remainder. Thank you for hearing.